you were asked to prove that AB is parallel to DE. Okay? So let me just highlight the two lines. So you're supposed to prove that AB is parallel to DE. So we're supposed to prove that those two lines are parallel. Now, first thing, the lines are not parallel, so you have to prove that they are. Now, if you remember when I introduced the converse of the proportion theorem, I told you that it can be used to prove that two lines are parallel. So this question required the use of the converse of the proportion theorem. Okay? Now, because we have some dimensions that were given here, okay, if we are to prove that AB is parallel to DE, we might have to calculate the length of BD, right? But before I go there, we're given this ratio, okay? So AE, I can call it 2x, and EC, I can call it 5x, based on that ratio. Okay? Then, I'm not sure how you did the question, but I'm going to calculate the length of FC first. Okay? I'm going to calculate FC, then I'm going to use FC to determine BD. Okay? So I have to find FC first. To find FC, I have to use the original proportion theorem. Okay? Find FC, I have to use the original proportion theorem. In which triangle? Well, for me, it's going to be triangle ACD. Okay, so in triangle ACD, I can write my proportion theorem. So I'm going to write it as EC. In fact, let me write what I want to calculate. Just write what I want to calculate first. The ratio of what I'm going to calculate. So that will be CF divided by DF. That will be equal to CE divided by EA. Or I can call it AE nicely. Let me call it AE. I hope you did the question. So that's AE. Then my reason there is going to be line parallel to one side of triangle, which is the original proportion theorem. So CF or FC, that's the one I want. DF is 10. CE, okay, it's 5x. And AE is 2x. Okay, as we have mentioned in the past, the constants cancel out. So CF is going to be 5 times 10 divided by 2, and then you get 25 meters. Okay, so CF is going to be equal to 25 meters. After that now, I can say BC is equal to BD plus DF plus FC. Okay, I want BD. I need to get the length of BD. Okay, so BD is going to be equal to 49 minus 25 minus 10. So that will give me 35. 35 from 49, I'll get 14 meters. So that's BD. Well, I'm smiling already. So I'm going to write this down now. Next page. Okay, then, but who's got a question so far? Right. I don't think this question will get any other way to do it except the way that I'm doing it. I doubt so. Because somehow, if you want to prove that these two lines are parallel, you have to determine BD so that you can apply the original proportion theorem. Okay, is there anybody who got these values that I'm getting here? Okay, let's get on then. So let's move on to the next page. Now, next page, I'm going to write, now because AB, okay, it has to be parallel to ED, I'm going to say EC over AE. So I'm going to say that okay, EC over AE is equal to 5x over 2x, which is 5 over 2. Right? Then, because of what I wrote here, I can also say CF over DF. I'll say therefore CF over DF is equal to, right, now my CF is what? 25. And my BD is 14. So CF is 25 over BD, which is going to be, no, it's going to be CD rather. So that I'm supposed to write the CD. Sorry, this is not correct. Let me write it as CD. So this is going to be equal to CD over BD. So CD over BD is going to be equal to, so I've got that 10 plus this 25 here, so I'll get 35 over what? Over 10. And this is the same as over what? 14. Okay. Over 14. Right, so the highest common factor there is a 7, so I'll get 5 over what? 2. Now then from here I can say therefore EC over AE is equal to CD over BD. Therefore AB. So this ratio, those two ratios are equivalent. Therefore AB is parallel to DE. Okay? Then I have to give a reason now. My reason is the converse of the proportion theorem. So it will be line divides sides of triangle, sides of a triangle proportional. I'll just write it like that. Okay, then you are done. So the key thing is to come to a conclusion. Okay, you can write out as a shortcut, it's fine. Okay, if you want to write it in full, it's okay, but your examination guidelines, they also accept that. Okay, so the basic idea is to prove that these two ratios here are equivalent. If they are equivalent, it therefore means that these two lines are parallel. Okay.